Hey, good afternoon, everybody. Thanks for being with us for yet another webinar this month. I think this is for sure a record. Maybe in our Lubrary heydays, we had a couple more each month, but this has been a pretty solid couple of months here with these webinars. My name is Maureen Gribble with UE Systems, and today we are pleased to have Jeff Hay with RDI Technologies here to talk about motion amplification. Really, really cool technology. If you've seen it in action at any of the trade shows, it's really, really something to see. So we're looking forward to him sharing that with us today. Just a little bit of info before we turn it over to Jeff. As we've mentioned, if you've been on these the past couple of weeks, you've heard this, but we'll just reiterate it. And for those of you that are new, we just want to make sure you know that in this crazy time, as we're all dealing with these changes and our lives kind of all being turned upside down, we just want everybody to know that we are at UE Systems and our friends at RDI and Iridicia. We're all here to be a support. Think of us as your personal ultrasound trainer. So if you're already a customer, or if you've got issues with software, you want some help, just learning the software better, help with any of your instruments, your programs, whatever it may be, we're all home and off the road and ready to hop on a webinar or a Zoom or whatever you want to do and help you through it and spend that time with you guys, because that's what we're here to do right now, and kind of just all hands on deck. So keep that in mind. Definitely reach out to us if you want to take advantage of that. We certainly love having people to talk to every day. So don't hesitate. We're really willing and able and excited to talk to people other than our families. And then I'll also just remind that there's kind of another initiative going on in the background with Iridicio and Friends Support. So those of you that know Iridicio, Sean Eisenhower, Darren Wyckoff, those guys, you see them out and about at all the trade shows and conferences. But they've got a web page that you can sign up for with additional, and aside from these webinars that we're doing, they've got some no-cost projects that they can help you with, videos, e-learning, things like that. Even if ultrasound or motion amplification is something you guys are wanting to kind of dive in on, they can kind of give you some tools to help you take some technology and actually get running with it. So just trying to find ways to, things that we can do, positive impact that we can make at a time where it maybe doesn't feel so positive. So we want to try and find those silver linings and see what we can do to make an impact and hopefully at the other side of this, be able to get off and running and look back on these days and know that we made the most of them. So there's that website there, help.iridicio.com, and all the webinars that we're doing, those are all listed there as well. So kind of a one-stop shop. Just some housekeeping as well. So we are recording this. So if you've got to hop off, or if you've got a colleague that wanted to see it and missed out, this will be recorded. We'll have it up on our YouTube channel, on our website. I'm sure RDI will put it up on theirs. I think Iridicia has been putting these up on their site as well. So multiple different places that you can check this out afterwards. We do welcome questions, so you can type those into the questions box, and I'll be keeping an eye on those. I'll get those questions tossed over to Jeff throughout the session if it makes sense, or of course we'll have some time at the end. We've got a pretty large crowd of folks with us, so if we don't get to every question, which I'm sure we will not, we do have a way of getting all those questions over to Jeff and his team so they can follow up and make sure everybody gets their questions answered. So please feel free to take advantage of that kind of interactive feature, if you will. And then just, I usually am just on here telling folks to just bear with us if we have any audio or Wi-Fi issues, because we are doing this live, but now we've got the added hazards of children and dogs and husbands and whatnot in the house. So if any fights break out or anything, just bear with me. I'll kick them all out as quickly as I can. So anyway, it's a crazy time for all. But with that, I'm going to turn the screen over to Jeff, and Jeff, we'll let you take it away.
Okay, thanks, Maureen. And I'll get my screen up here. I will also add to that kazoos. If you hear any kazoos in the background, my son on my last webinar decided to find the kazoo and started playing that nice and loud. So anyway, yeah. So I'll go ahead and jump in here and start. But I just wanted to thank UE Systems and Maureen for hosting this and putting this all together. I know lots of people are homebound, but it's still a lot of time to ask for you to take out of your schedule for these webinars. So I appreciate the time for doing that. So, okay, so I'll go ahead and get going. Just a little bit about myself. My name is Jeff Hay. I'm the CEO of RDI Technologies. And so my interest, I've got a background, I've interest in photography, so it's not kind of no surprise that I find myself here. But in my background's in physics, optical physics. I actually started in astronomy, and quickly found my way out of that. Just I think because I wanted to, be gainfully employed. It's interesting because the problem is very similar. We use cameras to measure something that's far away. You can't go to the object, you can't touch the object, and all the information you want to find out about the object, you have to get from the camera. And so in one case, it might be a star light years away, and in another case, it might be a motor or a pump that's vibrating in front of you. So remarkably similar in that respect. The technology was originally, I started doing this, in the 2005 or so. Originally for Department of Defense and DHS. So they were interested in surveillance and bridges and things like that, and then quickly started developing applications that we knew could have interest in the machinery market. And so I left there and started working for a large service company in the industry, a large condition-based monitoring company for a few years, and then went full time within the RDI to bring products to the market. So anyway, getting straight to motion amplification. What is motion amplification? Well, in a nutshell, it basically takes motions that you would not be able to see with the video and makes them visible in the video. So the right, you'll see maybe some side-by-sides in this presentation. The right-hand side is always going to be the amplified video. The left-hand side is a video, it's just unamplified. And so that's what you really see. That's what you see with your eye. So if you look at a car engine, you would essentially see, not a whole lot. But with a motion amplification video of a car engine starting, you can actually see that. So there's the car engine starting. So if cars aren't your thing, and maybe motorcycles, you can look at a Harley. But I think I didn't shoot this, but I'm told that I don't think you really needed a whole lot of amplification for a Harley. But anyway, nonetheless, there's a Harley motion amplified. So a little bit about the technology. So I've got some text here, but on the right-hand side is kind of a picture, of what we're trying to do here. We're really taking sort of what you see there, a spectrum, and really turning it into that video. So in some way, maybe some of you know what that spectrum is telling you. That maybe it takes some level of expertise to be able to diagnose that, to tell you what those peaks mean. But really, with a motion amplification, you can just see it right in the video, and you can see the misalignment across that coupling. One side's going up while the other side's going down, and it becomes sort of more of a universal language. So we're really making motions that are invisible by the eye, not by the eye, and making them visible to the eye. So essentially turning each pixel in the camera into a sensor. And then making a visualization of that. And then we can quantify that as well. Just a little bit else, in terms of the use or the benefits. If you've got sort of go into traditional vibration, if you put one sensor down, that tells you a lot of information and you get a lot of value from that. You can put a second sensor down, and then you can do interesting things like phase, and you get more, and then a third channel. And then you can start to outfit an asset, but it becomes, kind of expensive and cumbersome if you start adding more and more sensors to an asset. So by the time you're up to a dozen or two, you know, that's hard to manage in data and the collection. But with motion amplification, you can think of the pixel as being the sensor, and you add 1 pixel, 2 pixel, a megapixel, you know, is you know, kind of a thing of the past even, where we're up to lots of megapixels. So you can add pixels and then increase your sensor coverage across the entire asset very, very simply. So a little bit about some technical specifications. We're really measuring fundamentally displacement. I mean, that's really the fundamental displacement. That displacement measurement, and so that makes it really handy as a complementary tool to accelerometers. You know, accelerometers are a very common device or measuring device in this industry, and so now we add this displacement measurement, and it's a really good complement. The system's capable of live motion amplification, and I'll do a demonstration of that. You set the camera down, and instantly you can see the amplification. You can amplify up to 500 times, and then you can show the overall and frequency-based motion. So you're not just limited to show one frequency or another or combination. The first video that you see, you know, is overall. It's all the motion, so that's really important because you need to make a decision about what you're looking at and to be able to see them all. So it's really small detection capability, you know, 0.01 mils. So really, the system's capable of seeing anything of interest of any concern, and then some of the frequencies there that you can measure too. And then also it measures 2 axes. So you know, you get an up, down, right, left measurement, and it's synchronous across the entire image. So that's really kind of cool because now you can do phase relationships. Everything is taken at the same time. So you can make a measurement in the right side of the image and the left side of the image and compare those. And then also has the capability of measuring shafts while they're rotating. So a lot of people use it for actually measuring sort of what we call the operational run out, while it's in operation, how much that shaft is moving. So a little bit about the sort of the family of what they are. The IRIS-M is sort of I would say the standard motion amplification camera. You can add an MX to it. That's really just adding higher frequency. So if things are moving faster, you can see those things. And then also the CM, which stands for continuous monitoring. 3 cameras simultaneously collecting, can do 90 minutes of data per camera. In buffer, so it's kind of like a DVR. So that's kind of handy for lots of different reasons if you want to set something on it. It even does triggering with optical sensors. So you can draw a box and it will monitor that area continuously, and if something moves in that area by a certain amount, it saves the video, like pre and post that trigger. So again, that's for, you know, you sort of a crash cart, you put it on and you can put it on an asset and monitor overnight, a week, 2 weeks, however long you want. Some of the benefits of the technology, it really is a root cause complementary tool. So you know, in that sense, you know, it's not, motion amplification is not something that's going to replace the existing tools. You're still going to have your accelerometers, you're still going to have your ultrasound, you're still going to have your infrared. It's really just another tool in the toolbox that complements those other tools, and I'm going to talk through some of that and hopefully, you know, show you how it becomes a complementary tool. It's a really advanced and sophisticated data analysis piece, but I also like to think of it as 1 part data analysis, 1 part communication tool. Because one of the nice things about it is that it can really help communications between technical and non-technical users. It's really easy to show someone that something's misaligned or something's loose just by a video. I had one user tell me that he had been trying to get something fixed for 3 years, and he knew what the problem was. He knew what the problem was. He had been working on it for 3 years, and he couldn't get action taken because the people that had to buy into it were not technical, and they didn't really understand. And so shortly after he started using the camera, he was able to show the video, and then immediately got that asset fixed. So that's a really powerful piece of that. Again, improved safety. You know, it's totally non-contact. You know, you can make an absolute displacement reading from a distance without even going near the asset. And then sort of planned shutdowns. Every facility has a planned shutdown. generally, maybe not now, right now, but it's a way to be able to categorize your bad actors, figure out what's the severity is, and kind of come up with that plan. And then also, which is kind of relevant now is collection during operation. Everything that can be set down, you don't have to make contact with anything or go near it. So it gives you an advantage to be able to collect data while things are operating. And then a diverse application set. And I'll go into this in more detail as well, with piping and these different things like structures and processes and things like that, where, because of the nature of it being a camera, it allows you to go to some new areas and get more coverage across your assets. This thing sets up in a few minutes, and that's one of the things, maybe less than 10, you can be set up and going. And again, I'll give a demonstration of this here shortly. And then again, actionable information. I think that's a really powerful part of it, is that you can do something with the videos. You can share them and show them and send them via email. Real easy to be able to communicate this information to the people that you need to get buy-in to be able to sort of make the decisions to fix your assets. A little bit, about the industries. It doesn't have one preference into where people use it. Anywhere from pulp and paper to water treatment, automotive and anything essentially that's moving. It's a very fundamental measurement type. It's measuring displacement. So it sort of finds its home in a lot of different areas. So let's think about a little bit about a typical acquisition process. So this might be a traditional, where you're making vibrations, inboard, outboard, vertical, horizontal, axial, that sort of thing. So the idea would be, normally you would kind of do coverage like this, sort of notice that the base is not being measured. There's areas that really, it's just not, it's time prohibitive to be able to make measurements in those locations. But this is kind of the paradigm with motion amplification. So you have continuous coverage across the entire asset. It's a really cool tool that you don't know what you don't know sort of thing, and I'll talk about that later, but more in detail. But sometimes you see things that you weren't even looking for, you didn't know were there, and it wasn't what you were focusing on, but it ends up being the biggest problem. Again, because you're looking at just more than one location. So some of the, I said core pieces with this. It's the filtering here, so you can actually go through. You notice there's a spectrum. You can draw a box anywhere in the video, and you can make a measurement, and it gives you a time waveform in both the X and the Y, and a frequency spectrum in orbit. Again, anywhere you can draw as many as you want and do comparisons across different areas. But this is filtering. You can create any combination of filter that you want if you only want to show certain frequencies. And I'll walk through a short video here that I'm going to show you about filtering. And so what's going on here is, let's see if that's playing here. So these screens are moving at different frequencies. And then what we're going to do is we're going to go through and we're going to filter for an individual frequency here, and then show you kind of the power behind the filtering process. So what we're doing is we're picking a frequency here, and we're going through and filtering that for that frequency. And then now we can see we've got the peak here. We made a measurement. We're going to slide the sliders over, and we're going to pick an individual frequency here. And then we're going to go through and process for that frequency and show just that one, frequency. And now you can see that the video here. So I'm waiting for I think there's a slight delay in the video. So now we're showing only the pump motion here. And then we can also do the same for the footage for the individual screens as well. So we're going to measure that. So we'll measure the pump, and then show the spectrum for that. So you can get you can get the spectrum and the time waveform. And then there's the motion amplification footage for the pump. So again, we're going to now isolate the 925 RPM. And then now we'll isolate the 841 RPM. Okay, so that's just a little bit about the filtering there. Again, here's this would be a a typical acquisition that we'd do of a gearbox that would be moving, and then we can filter that for example, the output frequency of the gearbox at 2 hertz. And then here's the 25 hertz for just that motor. And then again, here's another frequency in the background. The something that kind of was not very obvious, but was actually the conveyor bouncing there. Which actually ended up being the biggest issue of all. What was kind of unbeknownst to them. There's also the ability to add stabilization, so that becomes important, especially if you're on a platform that's moving, and you can't always just filter it out. Sometimes they're at the same frequency, and so the stabilization works to remove the camera shake. And so a little bit of a demonstration in how that works. It's able to go through, and I'll show some of the stabilized footage where you can kind of see the motion overall, and then the stabilized footage. And then here's another shot here of the stabilization footage here. Now this was again all on a roof, so you can imagine the vibrations that would occur from the floor. Okay, so let me do a quick demonstration here. I think there's slight lag, so I apologize if I kind of get ahead. I'm trying to watch the audience view here to make sure that that it's caught up. So okay, so let me do a demonstration here. I'm going to do this live of the software. I'll pull the acquisition software over here. Okay, so this is the acquisition software. Again, it's pretty simple point and shoot. I'm going to turn this rotor kit on. And then again, I mentioned you can do live motion amplification. So if I do that, you can just press this button here, and then now you've got live motion amplification. So you can see the rotor kit move here, and then you can amplify it and then see it bounce. And you can increase or decrease the amplification, slow it down if you want. And then again, so this is really handy. You can just immediately scan assets. You can move this around. If you want to look at sort of the bass, you can scan around and look at the bass here. Or if you, for example, move over to this side, you can sort of move that part of the bass, see that part of the base or just anywhere. So again, you can just immediately set this camera down and then get the amplification showing, very easily, and scan entire assets in a matter of seconds. And then I'm going to take a short recording. So I'll do a short 2-second recording here and then demonstrate some of the capabilities. So I'll turn the live amplification off because I'm actually going to do a recording. So I'll do 2 seconds here really quickly. So I'll go straight into motion amplification here. Okay, so now one thing to notice is that in motion amplification, it takes 0 time to process anything. So I can go straight into amplification like this and then see this very, very quickly. And then you can make measurements just like this. So if I wanted to make a measurement here, I could do that. If I wanted to make a measurement here, I could do that. Again, that's all instant. And then to be able to do sort of phase measurements, I can drag and drop one onto the other, and I can see that those two areas are pretty close to being in phase. So on that bottom graph, you can see that they're in phase. So again, a real easy way to be able to do this, really quick. So that's just a little bit about the software, and I'll turn the rotor kit off and being able to see how that works and kind of the speed at which you can kind of get that. Again, the live amplification is fairly handy for being able to look at things like pipe work and that sort of thing. Okay, so let's talk about the integration into a reliability program and how that works with some of the use cases. So here we're going to talk about bad actors, some different use cases with bad actors and complex assets, getting the motion amplification used and the technology higher on the PF curve, or in this case the DIPF curve. So in the design and installation and commissioning phase, how it's complementary to a route-based method. And then new types of assets with the lack of coverage. So things like pipes and bases and foundations, they really largely can go unmonitored because they're a challenge. And then also to broaden the coverage, so maybe lower on the criticality scale. So maybe you've gone through and you've got your routes that you're monitoring certain assets, but maybe there's certain things that are left off those, or there's certain things that don't get as big of a look or get covered at all. But the speed at which the technology can work with being able to go down and set it down and see things live and be able to measure, on the spot, gives you ability to look at a whole new level of assets in your facility. And then also a comprehensive scan. You really don't know what you don't know, sort of thing. So it's remarkable what you can look at and see and get out and with the camera, with the motion amplification, and then see things that you didn't know were occurring. So let's see. I'm going to drop the resolution here on the screen and see if that helps with the playback here. Okay, so we'll go into this. So we'll go into first bad actors and complex assets. So this is a case study. This is a bad actor case study from Loy Yang in Australia. They had invested $120,000 into this asset over 11 years. And the reason why that number is kind of so high is because the OEM was still on the hook for this. And so because of that, they sort of got them to keep doing repairs on it for that time. And then there's about 500 man hours expanded on this, and the problem still existed. And so motion amplification was used, and then within an hour, they were able to identify the root cause of it. So we're going to walk through that through videos of that. But what it ended up being, and you can watch through this, is a structural integrity of the base. So this was, they were able to capture that and understand where that problem was And then now they're confident that this asset has been repaired properly. One of the real kickers was that prior to motion amplification, they had planned to do a whole new set of repairs with this. And as it turns out, those repairs would not have fixed it. So that 120,000 would have ticked up just a little bit. So this, the MA allowed for quick root cause and identify the issue. So here we're going to look at it and see this motor pump combination. So here you can see the pump motor. I mean, immediately you can kind of see with this with this issue of what's going on with it as it's sort of moving so much. So we're going to take a look all the way around it. You can kind of see it move on its base. And then we'll take a look. This is pretty common, the way that the person scanned all the way around. And you know, you're going to get a good look at you're going to get a good look here right now at the base issue. And then we'll show some measurements where they actually went in to confirm this. So you can kind of go ahead and see this is one of the shots that actually clued them in to where the corrective action needed to happen. We'll take a closer look here. And then here's a shot on the other side as well. So this shot I like coming up here because it shows, I think, where they put a lot of their attention. They really were chasing the vibration, just finding the areas where the high vibration levels were and stiffening it, you know, I mean, and which could have actually caused more problems than it helped, in that it transferred some of the energy back into this this motor and pump. So, but you can see where they had added, you know, braces and supports, probably because the vibrations were just high there. And so here, you know, you can see that where they made the measurement. I'll see if I can highlight this where my mouse is here, kind of moving. But there's a red square on that base and a blue square on that base that you can see. And what it turns out is on the upper, there was about 2 mils peak to peak. And then on the lower, there was 0.4 mils peak to peak. So there was a difference there. One was moving more than the other, which clued them in on the base being insufficient. And so the root cause was identified. Here, the root cause was identified. Vibration was reduced from over 0.5 inch per second to about 1.15 inches per second. And this was before aligning it, you know, doing an alignment. Again, I didn't get the numbers after the alignment, but I think there would have been expectation for those values to go down. So here's some before and afters, which I think are always really cool to be able to get to see, because lots of times in the after shot or the after data collection, people don't always, once they're fixed, it's fixed. They don't return to it. So a little bit of a before and after. Here's another before and after. So this video is not the same, but I like showing it because it shows the repairs. So you'll see the repairs, and it's just a nice video to show, you know, how simple the repair is, but it's not always obvious. You know, it's hindsight's 20/20, and a lot of times, so it's really easy to see it once you see it in the video, to think you should have saw it all along, but that's not always the case. So here's another sort of hard asset, bad actor kind of hard asset to look at. This is a structural issue where one of those towers was moving at 1.4 hertz. So this looks like a fairly big sort of a fairly big problem. But as it turns out, the problem wasn't as complicated as you would think, in that the frequency there happened to be the same frequency as an agitator. So really, it was as easy as moving changing the frequency of the agitator. Here's another challenging one of a torsional resonance in a pump, and this is tricky. They had quite a few sensors on this already, over 20 sensors, but they couldn't capture this torsional mode, and so they brought the camera out as the only way to really capture it in this scenario they were under. So again, they were able to capture it because they could see it and identify it. And again, this was one of those identifying the mode, identifying the frequency, and then knowing what frequencies they need to get through while they're bringing this thing up online to not hit those frequencies. And then one more, which is this is a roller coaster, and this is actually the roller coaster when the coaster goes over and it's lifting. So again, this was a scenario where can't go in and make contact, especially while it's in operation. Also, you've got to worry about people seeing you if you're in an amusement park, that sort of thing. So you could go in and make this measurement and find out how much that lifting was occurring with the camera, and visualize it as well. So higher on the PF curve, or the DIPF curve. So let's talk about that a little bit. So here we have, sort of the PF curve. So the idea is to try to get your technology as high on that curve as possible. Find the defect as early in the life of the asset as possible. A lot of times what ends up happening is this sort of circular thing happens where if you don't identify the root cause, you sort of repair something, maybe a looseness that's caused from something else that's gotten worse over time and worn itself loose. So you do that, and this continual, and then eventually it comes back, and then it's cyclical. Whereas with the IRSM, what we like to try to educate people is get into this design and installation and commissioning side of things, so that you get more bang for your buck in putting it in that area. And so we'll talk about here one about a commissioning of a new facility, a mining facility in Mexico with Goldcorp, where they had brought it in to bring a new facility online, and they found this tank. This was one of the first things that they looked at. What they did is they did acceptance criteria with the camera to every new asset. So as this facility was coming online, anything that was coming online had to be looked at with this with the camera, and they found this. And here's the back view of that tank. And of course, the conversation goes something like this. Hey, there's a problem with this tank to the OEM. The OEM says, nope, this is not our issue. Everything was fine. And then you show them the video, and that conversation quickly changes. And that's the case here. They said, yeah, you're right. We got to get in and fix that. And so the OEM did come in and fix it on their dime. And then this was the repair shot, where everything looks good. Still some movement, which is normal to have some, but just wasn't acceptable for it to be at the level it was before. And then there was also an SO2, 500 degrees C gas flowing through these pipes. And they found a heavy vibration. It would have caused a failure. It would have eventually caused fatiguing and caused a failure, which would have been deadly at that point. And so this turned out to be an as designed and as built spec did not match. So they sent it back to the engineers, and turned out they just didn't build it right. They designed it right, but didn't build it right. And so this was a catch by them. Again, tying commissioning to this. Again, it kind of goes to the speed at which you can do this. Okay, so let's talk about how it's complementary to route-based methods. There's a large group of users who just simply tie it to route-based methods, in the sense that they do their normal routes. This isn't necessarily something everybody's going out and replacing routes with, but when they get an alarm, this is a technology that they will go to. So because they can also get a high one times, and it can be 20 different things. I mean, some are more common than others, right? I mean, you got your, sort of looseness, there's some things that might generally be more common, but sometimes you're kind of chasing that vibration. And so in this case study, you're going through and showing you sort of the vibration levels that the thing was experiencing, the high 2 times in this case. And so they checked everything, you know, alignment was good, no softbed issues. And so they brought in the IRSM camera to take a look, and immediately when they, you know, they shot it, and here's sort of the standard HD video of the motor running, and then they'll apply the motion amplification footage, and you'll be able to see with that the motor vibrating, which you expect. You know, everything's going to move to some degree, but it's really trying to find out what's the cause, what's the root cause of this vibration issue, which turns out to be really kind of challenging in this issue, because you don't always, you know, look in these areas or think to look or put a sensor down here. And this turns out to be the case where there was separation in this video, or separation in this you know, in the video showing from the base and the support there. And again, really trivial to show with the camera, but very challenging to be able to do something like that with normal contact sensors. Talk about another one. This was again a route-based measurement, you know, kind of tying in with route-based, where the amplification was brought in. You know, they get a high vibration reading, triggers the alarm. What I like about this is that it was immediately corrected. They were able to bring out the camera, get an alarm level, bring out the camera, find the issue with the camera, and then immediately fix it. Turned out to be a trivial issue, right? And that's great. I mean, that's, in some ways, that's what you want to find that it is. But it's really about finding that issue. Again, and then with the camera, it becomes a little bit easier to do that. And so they go in and find this base sliding, and it turned out to be that they needed to tighten it down. And so they were able to go in, look at it, and this was all done in the course of 30 minutes. I mean, this is a really quick process from going from you know, sort of getting the alarm, getting the camera, making the repair, and then moving on. So here we're showing the sort of the motion and the vibration of this thing sliding, and then we'll show a little shot here where they issued the work order, tighten down all the holding bolts, and then I like this because they show, in this case study, show a couple shots of them actually doing the repair. And then vibration, 60% reduction in vibration levels. And there's a before and after. So, the other piece, the next one, in terms of where it fits into the reliability, would be new types of assets. So with a lack of coverage. So the first one that I want to focus on is just piping. I mean, this is a real big issue, and it's a safety issue often, and it's just a big challenge. And where do you even start, right? Where do you start? So with a camera, you're able to set it down and scan in a very large area in a very short amount of time, and be able to see, all this motion, and then pick and choose what is good, what is bad. You can measure it all, and then make a sort of a course of action. And again, with the live amplification, you set the camera down, you see it. You don't even have to take a recording. You scan the entire thing in a matter of seconds and be able to see all the vibration everywhere. So that's one. And then here's another piping that where you go in and have a little bit more complicated of an environment. Here's again amplified and unamplified footage. Right side's amplified, left side's unamplified. And then to be able to go in and make a decision. Here, it was quick enough that they could do this entire area with different scenarios, with different pumps running, so that to be able to see what was going on and then make a decision right then and there. Again, real quick, no outfitting with sensors. This is all done pretty rapidly. Okay, so talk about a little bit about broadening the coverage. So again, you might have a certain percentage of your assets covered with some technologies, some with accelerometers, some with others. But the idea is that because the speed of the camera is so quick and it covers such a large area, that you can encompass a larger set of assets. So maybe that small motor and that a pump just that don't get covered now can be covered. You can look at it, pretty quickly. And so this is one of those that the operator knew of the problem. He's known it's been existed for a while, but no action was being taken. But again, if you're able to just spend 30 minutes on the problem, then that becomes something that people sign off on. And so it becomes easy to be able to get the camera in. So again, here you go in and look at it. We're sort of chasing this vibration by scanning around. We look at the feet to be able to see. We determine that 1 foot's not vibrating. So that's good. Let's continue the scan around the asset to be able to see. Again, and this is something that just might not be covered, because it's just not the criticality, the value of the asset. Oh, so we can see one side of that vibrating, and then we can see that foot now vibrating. And this turns out to be the issue. We catch it. It turns out to be that bolt was drilled at an angle when it was installed. This fault flaw had been there from the beginning, and pulling it back out and then re-drilling that at the proper angle ended up being the solution. So a comprehensive scan. This is another area where, again, it's just you don't know what you don't know, and this is one of those things where you go through and you're really surprised to see. This was a scan, complete scan. It wasn't, there was no something that brought them to this. They were going to do a scan of these pumps and the motors and look at that, and they came across this issue. So again, this is one of those that would have been a real challenge. We're going to see a shot here in a second where it's a concrete issue being loose. And you can see this lifting in this concrete. Again, to be able to get an accelerometer or some other technology in here would have been a challenge, and that's why, sort of we say this is a really good complementary tool to be able to get in there and look at this sort of thing with a camera. Okay, so we're getting close to the end. I want to talk. We just did a big software release, so I just kind of talk about some of the new features here in 3.0. We talked about live motion amplification. That actually just got released. Set the camera down, no wait time. You're live. You can scan areas in an instant and very rapidly with the technology. So also just sort of motion vectors. These are kind of cool because they really show relationships really easy. So you can really help people, educate people with things like phase. One vector is going up on one side while the other is going down, that sort of thing. Really just demonstrate motion really well. Just another way of being able to show it. You don't have to amplify the video to put these on. So if that becomes sort of a distraction, you can put the vectors on. Transient ROIs, kind of cool. Up until now, it really was about a fixed object that was sort of vibrating. Now you have the capability of tracking motion all through the video, measuring the global motion of that object, the dynamic motion, so the vibration that's sort of vibrating, as that thing moves. So like overhead cranes and robots, you can actually measure vibration and get spectrum of moving objects, dynamic and transient data. So like AC and DC kind of thinking, all from the video. And then transient motion amplification is interesting. In addition to the transient ROI, you can now measure and amplify footage of things that are moving. So things that move all the way through the scene largely or sometimes could be a challenge for motion amplification, but that's sort of been with progression of the technology. You can now amplify the big and the small motion at the same time. If an object moves all the way through the scene, you can amplify that and show the little tiny vibrations, like on this cutting tool that will progress all the way through the video. The motion amplification can handle that to be able to show small vibrations on top of large vibrations. And then finally, the last one is motion map. So this is a cool technology that was requested by a lot of users, and so it allows you to do a color map. So this is motion map, and you can show individual frequencies of motion. So you can highlight in sort of like a thermal image. Red is more intense and blue is less intense, and show where the motions are, and this really helps you understand relationships. You can combine this with the motion amplification and the various other tools, but it's a real quick way to scan an asset or scan a scene and see all the different relationships between all the different objects. So, okay, so I think we're about the 10 minute mark. I'm gonna stop there and handle any questions. I will say I'm not sure what the experience was. It's a fairly large amount of people, and I know the internet's probably being stretched to its max. So I will say this: if some of those videos, you know, on my end, they're all fluid and smooth. If some of those did not come through for you, don't worry. We'll make this. This presentation will be made available, and then if we can also handle the being able to make some of the videos available as well. If for some reason on your end the download speeds weren't very fast.
Awesome. Well, it looked good on my screen, so hopefully the recording then that I was doing should all look pretty good. So as we mentioned at the beginning, since this was recorded, we'll have it up online. So definitely check that out, or reach out to Jeff and his team, and they can hook you up with those examples. But yeah, did not disappoint. That was really cool, really great information. Hopefully everybody got a lot out of that. We'll just hit a couple questions that I kind of saw some common themes. So we'll hit those, and then as I mentioned at the beginning, since we're a little low on time and we have a lot of folks, we'll be sure all these questions get over to Jeff and his crew, and they can follow up with you guys offline and make sure all those questions are answered. So just in that spirit, a lot of folks were kind of asking around alarm levels, so different kind of questions about how do you set alarms, how do you kind of determine the severity of what you're seeing, and kind of at what point you're really needing to make a jump and make some repairs or decisions.
Yeah, that's a good question. So yeah, I think for the technology, you can show the measurements in displacement or velocity. So this is really generally mostly used as a troubleshooting tool, not something. We have the continuous sort of monitoring capability, but for us, really the same rules apply. Half of an inch per second is bad on a motor, then it's going to be the same with us. So there aren't necessarily pre-built alarms, with it. It's more of the tool that gets you that data to make those decisions. But the same rules still apply. There's nothing, no new rules of vibration. So if you go through and measure it, and the values are normally too high at that, at 30 hertz, half an inch per second is bad. For a certain type of motor, then that same rule will apply. That said, there are a lot of cases where it's absolute. It doesn't matter what the values are. That's a problem. And best practices dictate that you take that out at your next downtime. Like, for example, a soft foot, or sort of a severe misalignment or things like that. But like, certain levels of looseness, or, we saw that concrete moving. Those sorts of things are dead giveaway. So lots of times, you can make the measurement and get those values, but the video itself that a lot of times people make that repair based off of, just seeing what the type of movement it is.
Awesome. Okay, and then we'll do one more, but again, it kind of comes from several different folks asking similar things. So how do you handle kind of things like, what if there's steam in the area, or different types of light reflections, different temperatures, different just kind of conflicting visuals that might get in the way? How does the system handle that?
Yeah, that's a really good question. So yeah, so we've added a new element. When you put a sensor on something, it's like in contact with it, right? There's nothing in between you and it, and now we've got this camera. It's an environmental, situation. So steam's a good example. We sort of have a rule of thumb: if you can see it, you can measure it. Steam, is interesting. You can actually get rid of that quite a bit. Steam generally prefers certain frequencies, and when you filter, you can filter a lot of that out. Light flickers the same. There's ways to make sure when you collect the data that it doesn't even get in the data. But for example, if it does get present, you can easily filter that out. So there's some things that you can do to eliminate those those things in the data. Some of that's done through filtering and some other techniques.
Okay, awesome. Well, let's wrap things up here. Again, great presentation, Jeff. Clearly engaged a lot of folks, a lot of questions coming in, a lot of just, thanks and things like that. So again, folks, we'll get those questions answered, but just want to make everybody aware of the webinars that we have coming up, and we've got more that we're going to be planning, so this list is going to grow. But tomorrow we're going to be talking ultrasound, so that's our wheelhouse here at UE Systems. So if you're able, tomorrow at 1 o'clock, we're going to hop back on here and talk all things ultrasound with Adrian Mester. I know a lot of you know him and have seen him out and about at different conferences and things. So definitely make plans to join us for that. And then next week, we're going to have James Kovacevic from Erudicio, another conference favorite. And he's actually on with us. So James, do you want to say a few words about what your presentation is going to talk about?
Yeah, absolutely. Thanks for the opportunity. So job mapping, how to develop great job plans. So there's a lot of conversation going around about how detailed do we get with job plans? How do we develop those job plans that are going to be repeatable, consistent? How do we get good time estimates? All those things around, structuring great job plans. The presentation next week, we'll walk through a method known as job mapping that allows us to essentially break down the activity that we're doing to the various levels of detail required and assembling that into a good job package. It's a visual technique. It's highly hands-on. We're going to walk through that approach and make sure everyone has the opportunity to develop a good job plan. And continuing on with, Erudicio supports, after we walk through that, I highly encourage you guys to do a job map, convert that to a job plan, and send it on to myself or Sean or one of the other coaches at Erudicio. We'll be more than happy to look at those and go through that with you. That's about it.
Awesome. All right. Great. So an invite for that, those that for next week, those will all be going out on Monday. Maybe we'll try and get some of those links up on social before that. And then next Friday, another UE Systems specific. But for those of you that have been with UE Systems, we're going to kind of just do a little refresh on how to get the most out of your UltraProbe 15,000. So if that's of interest for you guys, we'll be doing that one as well. So again, the point just being, let's try and all, stay together on this and provide as much information and help and support on various different initiatives that you guys all have going on. And, we're really thankful for everybody being able to kind of pitch in and help us out on this. So with that, there's our contact info. You got my email address there, our office phone, website. Any questions you've got, I can, get you guys in touch with Jeff. I can get you guys in touch with the folks at Erudicio. So don't hesitate to reach out to us. But again, appreciate you all spending your lunch hour with us. I hope you enjoyed the presentation, and hopefully we'll see some of you guys here tomorrow. And again next week. And in the meantime, we'll catch you guys later. Have a great day.